If you pointed your eyes toward the edge of our solar system today, you would not expect to witness anything dramatic. Neptune, so distant that sunlight arrives there as a pale whisper, was always considered one of the quietest worlds in the planetary family. But Webb's newest infrared images have shattered that assumption. Something is happening on Neptune, something scientists did not predict, and the more data Webb sends back, the more confusing the picture becomes. This distant ice giant is fading, cooling, brightening, dimming, and shifting in ways that simply do not match existing models. And that is where our story begins, with a planet that should be stable, yet behaves as if a deeper engine has suddenly changed its rhythm. Neptune is normally a world of slow transformations. It takes 165 Earth years to complete a single orbit, meaning its seasons last for decades. For generations, astronomers assumed nothing major could change there on human timescales. But when Webb looked at Neptune with infrared clarity, far beyond anything we've had before, it revealed puzzles that contradict decades of assumptions. The planet's upper atmosphere is cooling at an astonishing rate, significantly lower than measurements taken in the late 20th century. Regions that were once bright in infrared now appear strangely dim. Clouds that dominated entire hemispheres seem to have thinned out or vanished, and storms that once raged with record-breaking winds look weaker and more fragmented, as if the atmosphere is reorganizing itself. This goes far beyond normal seasonal variation. It suggests Neptune may be undergoing a larger and more rapid shift, one that scientists cannot yet explain. What makes this discovery even more remarkable is how difficult Neptune is to study. Too dark for ground-based telescopes to see clearly, too distant for spacecraft to reach easily, and visited only once in human history, Neptune has always remained on the edge of our understanding. And now, just when we thought we finally understood its behavior, Webb has revealed something entirely unexpected. Neptune is changing far faster than any theory predicted. The question is, why? To understand Neptune's sudden transformation, we must revisit what this planet is and why it behaves so differently from the gas giants. Closer to the Sun, Neptune is an ice giant, composed mostly of hydrogen, helium, water, ammonia, and methane, in exotic states created by extreme pressure. Beneath its clouds lies a deep mantle of superheated ices and, at its core, a rocky interior that radiates heat outward. In fact, Neptune releases more internal heat than it receives from the Sun, a property that has always fascinated scientists. It is this inner warmth, not sunlight, that fuels the planet's ferocious winds and storms. Yet Webb's infrared data suggests that this internal heating may be changing. Over the past few decades, Neptune's upper atmosphere has grown significantly colder, by tens or even hundreds of degrees in some regions. A world so far from the Sun should not cool this fast. This rapid temperature drop has altered methane distribution, cloud formation, and the visibility of Neptune's atmospheric bands. In some latitudes, clouds have nearly disappeared, while in others, thin streaks appear where we didn't expect them. Even more surprising is that Neptune's mid-latitude aurorae appear brighter in Webb's images on Earth. Strong aurorae typically correlate with energetic particles and atmospheric excitement. But on Neptune, the opposite seems true. As the upper atmosphere cools, the aurorae intensify. This contradicts current models of how auroral processes should behave on an ice giant. One theory suggests that Neptune's magnetic field, tilted dramatically and offset from the planet's center, may be changing how charged particles interact with the atmosphere. Another possibility is that Neptune's internal heat flow, long thought to be stable, is fluctuating. If the internal engine has slowed or redistributed energy differently, it could explain the cooling, the cloud loss, and the atmospheric weakening Webb detected. But even these theories struggle to explain the speed of these changes. No planet so distant should shift this quickly, and so the mystery deepens. Neptune is giving us signs of a planetary scale transition, but we still lack the pieces needed to solve the puzzle. As Webb continued monitoring Neptune, another set of anomalies appeared, this time in the storms and atmospheric circulation. Neptune's storms were once its most iconic features. Voyager 2 captured massive dark vortices swirling with near-supersonic winds, structures large enough to engulf Earth. Yet today, Webb sees fewer large storms, weaker winds, and vortices that fade more rapidly than expected. It is as if Neptune's once powerful atmospheric machinery is losing strength. But why would this happen? One possibility is that changing temperatures have disrupted the balance between rising and sinking air masses, altering how storms form and decay. Another possibility is that methane condensation, which helps create the bright clouds Neptune is famous for, may be occurring at different altitudes than before, reducing cloud density. Webb's data also shows surprising variations in brightness across the planet. In infrared wavelengths, regions that were once warm are now cool, and cooler regions show unexpected pockets of heat. This suggests that heat transport inside Neptune may be shifting. Even the planet's rings contribute to the mystery. Webb captured the faint dusty arcs with unprecedented clarity, but it also revealed subtle changes in their brightness and distribution. Ring arcs that once appeared stable now seem slightly altered, as if external forces, tiny moons, micrometeoroids, or gravitational resonances, are reshaping them over time. And then there is Triton. Webb's infrared view shows Neptune's largest moon shining brighter than the planet itself. With its reflective nitrogen ice crust and active geology, Triton may be influencing Neptune more than we realized. Scientists suspect magnetic interactions between Neptune and Triton might affect atmospheric behavior on the parent planet. While still speculative, the timing is compelling. Triton's seasonal changes coincide with the atmospheric cooling Webb detected. Taken together, these findings reveal a planet in flux. Neptune is not drifting quietly through the darkness. It is undergoing shifts across its atmosphere, temperature, storms, magnetic environment, and possibly even its internal heat. Something deeper is happening, and Webb is only beginning to uncover it. So, what does all of this mean? Neptune is acting strangely, far more strangely than any planet so distant should. Temperature drops on a planetary scale, weakening storm systems, shifting methane clouds, and aurorae that defy expectations all point toward a deeper process unfolding beneath the surface. Perhaps Neptune's internal heat flow is changing. Perhaps the planet's seasons are more extreme than we realized. Or perhaps Neptune is simply far more complex than the models built from a single Voyager flyby ever allowed us to understand. For now, scientists remain cautious. Webb's observations are still new, and interpreting atmospheric patterns on a distant ice giant is extraordinarily difficult. But one thing is clear: Neptune is not the stable, quietly orbiting world we once believed it to be. Instead, it is restless, changing, and capable of surprising us even after 175 years of study. And this matters for more than curiosity. Neptune's behavior influences everything from the distribution of objects in the Kuiper Belt to the long-term climatic evolution of the outer solar system. Its gravity shapes the orbits of icy worlds, while its magnetosphere interacts with particles streaming outward from the Sun. If Neptune is undergoing a shift, it may reshape how we understand the architecture of our entire planetary system. Sadly, no spacecraft is currently headed toward Neptune. NASA's budgets leave missions to the ice giants uncertain, and the next opportunity for a gravity-assisted grand tour won't occur for many decades. Still, the possibility of China launching a dedicated probe in the 2030s offers hope, because if Webb has shown us anything, it's that Neptune is far from fully understood. More secrets lie below those swirling clouds, secrets we may uncover only by returning. Until then, Webb's infrared images stand as a reminder of how little we truly know about the final planet, and how even in the vast, dim outskirts of our solar system, something extraordinary can still take us by surprise. Neptune, acting strangely once again, has captured our imagination, and it may be only the beginning.